Hello students, today I will discuss about random process, its definition and how this is different from the random variable. Since you know that a random variable is nothing, it's a rule by which you assign to every outcome of an experiment a number. That means you are assigning a number to the outcome of an experiment. That's called a random variable. Since for random variable you are not assigning any time, now here for random process or stochastic process we will be assigning to every outcome a function x t of zeta, x t zeta, such that time will be introduced here. That means my outcome will be assigning to every outcome a function x t of zeta. That means time will be introduced here. Thus, a stochastic process is a family of time functions depending on the parameter zeta, or equivalently a function of t and zeta. The domain of zeta is a set of all the experiment outcomes, and domain of t is a set of all real numbers. That means domain of t will be all real numbers if now this domain will consist of the continuous time process. If r is a real number, if r is a set of integers, then this will be a discrete time process. Now I will give brief outcome about this. How can you describe a random process? Suppose consider a random experiment of tossing a dice at t equal to 0 and observing the number on the top of face. So once you toss the dice, what you will get? You will get simply S, that means sample space. It will be equal to 1 2 3 4 5 6. So I will list it in a table of form. I will try. So outcome is 1 2 3 4 5 6. Function of time, since this is a function of time, I write this as x1 of t, this is x2 of t, x3 of t, x4 of t, 5 of t, and x6 of t. I have randomly declared this. Let this function of t be equal to 4 minus 4, this is equal to minus 2, this is equal to 2, this is equal to 4, minus t by 2, t by 2, and t range should be from 0 to infinity, 0 to infinity. So all these outcomes are function of time, they're dependent on time. So we can say the set of all these functions of time, x1 of t, x2 of t, up to x6 of t, it represents a random process. That means this is a random process where we assign a number such that we get x s t. That means it's a function of s. S is nothing but your sample space, and t is nothing but your time. That means this x s of t is a function of sample space as well as time. Now suppose if my time will be fixed, then what I will get? This will be simply x of s. This is nothing but your random variable. If t is fixed, then this x s of t is your random variable. If both are variable, then you will get your random process. This describes the random process. Now if both are constants, s and t, they are fixed, they are constant, then you will get nothing but a number. You will get a number. So I hope you people have understood brief concept about random process. Thank you.